The periodic table of elements is a table of all the elements that we know of, such as hydrogen, carbon, nitrogen, and oxygen. These are the most common elements as they are also used in biology. And the elements are divided into columns and rows depending on the properties they have. Before we start off with what properties they have, let's name something that is very basic. The periodic table is divided into two main parts. One part consists of the metals, which is a great majority of them, and the other part is the nonmetals. Alright, I divided the periodic table into a line right here beside the left of carbon and phosphorus, selenium, iodine, and down. And something you should know is this side of the periodic table right here, these are the nonmetals, but also it consists of hydrogen. Hydrogen is also a nonmetal. It is on the other side of the periodic table though. Alright, now let's start off with the families of the periodic table. Yes, the periodic table is divided into families depending on their valence electrons, which I'll move on to a little later. Alright, the first family is the alkali metals. The alkali metals is the first column. The alkali metals does not consist of hydrogen. Hydrogen is a part of the halogens, or nonmetals you could say. So the alkali metals consist of lithium, under is sodium, under is potassium, and then rubidium, cesium, and francium. That is the alkali earth metals. So I'll put alkali. Oh, that's not earth metals. That's just alkali metals. So I'll put alkali metals, Am. And the second column is the alkali earth metals. So that consists of beryllium, magnesium, calcium, strontium, barium, and radium. So this is the alkali earth metals. So I'll put Ae. Everything right here, all these elements that are a little lower than all the elements, these are the transition elements. Transition metals. So these, you do not have to call them by their family name. They're just called the transition metals. Alright, so let's move on to the other elements and their families. So let's start off with the blue ones. The blue ones right here, which consists of carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. These are the halogens. And all the yellow ones right here, these are the noble gases. So I'll put Ng for noble gases. Alright, all the other non-metals that you see on this side of the periodic table, all the non-metals which don't have a family name, you could just call them non-metals. Alright, so moving on from the families, let's start off with another reason why they are organized in this way that is so bizarre. Alright, so starting off with the first column, which consists of hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. All of these elements have one valence electron. What does this mean though? One valence electron. So in the Bohr-Rutherford diagram, you have circles who signify the rings for all the electrons. So one valence electron would mean one here. Let's put two here, two over there, also two over there, and say it has one on the last ring. This is the valence electron. The valence electron is the last one. So all of these have one valence electron. I'll put a 1 VE right here, and the second row has two valence electrons. As you can see where I'm going here, the third row has three valence electrons. The fourth is 4, 5, 6, 7, and 8. Now, moving on to a more difficult part of chemistry. Now that you see, I'm going to use a very common compound, NaCl, right? They combine and they react because sodium is a positive. Because when it turns into an ion, sodium only wants to lose one electron. So when you lose an electron, if you lose something that's negative, you become more positive. And chlorine is more negative because chlorine is right here on the periodic table. It has 7 valence electrons, so it wants to gain one more. So once it gains an electron, it becomes a negative. So that's why sodium and chloride come together, because they want to neutralize each other. Alright, so that is another aspect of why they are divided into this area, these rows and columns. Now let's take one element as an example. Let's take carbon, as it is very common. Carbon has an atomic number of 6, which I'll explain, and an atomic mass of 12.011. Alright, so the atomic number is the number on the number that the element is given. So as you can see, hydrogen is number 1, helium is number 2, lithium is 3, beryllium is 4, boron is 5, and so on and so forth. So carbon is number 6. The atomic number is equal to the number of protons that the element has. So as you can see, the least amount of protons that any element has is hydrogen, and the most would be lawrencium. Alright, so moving on, the number under it. This is the atomic mass. This is simply the atomic mass, which is the mass of the element. So this is the atomic mass. Let's put a line right there. Alright, so now C. C is the big letter in the middle. As you can see, there's H for hydrogen, Li for lithium, Be for beryllium. This is the symbol. So right here, this is the symbol. Alright, now you can see, moving on down here, you can see all the different types of families. You have alkali metals, alkali and earth metals, transition metals, which are all these elements in the middle. There's basic metals, which I talked about, which are all the non-metals, which are all the metals that are not given a name. There's semi-metal, which in most scenarios we don't go through. Non-metals, which these are also called halogens, and noble gases, and these two are not really talked about as much as the other families. Alright, so that was some basic information about elements and the periodic table, why they are divided into these columns and rows. A quick review is the first row are called alkaline metals, and they all have 1 valence electron. The second row is called the alkaline earth metals. They all have 2 valence electrons. And the third row, past all the transition metals, which is boron and everything under, they have 3 valence electrons. The fourth row has 4 valence electrons, including carbon, silicon, and so forth. The fifth row, which is nitrogen and phosphorus, has 5 valence electrons. The sixth has 6 valence, 7 valence, and 8 valence. Something you should know is about these valence electrons that metals will always create. Sorry, let me clear up some space. Metals will always create positive ions. So metals will always create positive ions, and non-metals, such as oxygen, will always create negative ions. The reason for this is that the metals always want to lose an electron because it is closer for them to become stable. That is the goal for every element. They want to become stable. So once you lose an electron, you become more positive. And the non-metals, they always want to gain an electron because they're so close to having the full orbit. So you have one last electron to gain. Example for fluorine, it needs one more electron to become stable, so it wants to gain 1 electron, and once it gains an electron, it becomes a negative ion. Alright, that was some background information about the periodic table of elements and why they're divided into these rows and columns. Thank you for watching.